Have you ever wondered what everything in the universe is made of? From your phone, to your body, to the stars in the sky? Everything around us is made of matter, and matter is made of tiny building blocks called elementary particles. These particles are the most basic units of nature and cannot be broken down into anything smaller. At first, scientists thought atoms were the smallest particles. Later, they discovered that atoms are made of smaller particles like electrons, protons, and neutrons. Even more surprisingly, protons and neutrons are made of even smaller particles called quarks. These particles interact through four fundamental forces: gravitational, electromagnetic, strong, and weak interactions. These forces control everything from holding atoms together to powering stars in the universe. In this video, we will explore how elementary particles interact, research based on elementary particle, and why they are important in our daily lives and modern science.
In the early universe, when energies were vastly higher, the laws of physics took a simpler, more symmetric form. Grand unified theories propose that the strong, weak, and electromagnetic forces merge into a single force at extremely high energy states. As the universe expanded and cooled, energy levels dropped, symmetries broke, and the forces separated into the distinct interactions we observe today. These theories predict rare remnants of that unified era, including processes such as proton decay. Traces of this unified era may still appear in rare phenomena, such as proton decay, and in the ability of neutrinos to change flavor, oscillating from nu-e to nm, as their quantum energy states evolve. What about the Standard Model? Standard Model was highly successful but incomplete. Help us move closer to a full understanding of the universes.
The theory of Standard Model and beyond. The Standard Model explains the basic building blocks of the universe. It describes fundamental particles and the forces between them. However, it does not explain everything. The Standard Model includes quarks and leptons, which make up matter. It also describes three forces: the strong, electromagnetic, and weak forces. Gravity is not included. Although the Standard Model works very well, it has limitations. It cannot explain gravity, dark matter, or the values of particle masses. To solve these problems, scientists study new theories. These include supersymmetry, force unification, dark matter models, and string theory. Each theory extends the Standard Model in different ways.
Technology particle, in Large Hadron Collider, LHC.
That's so fast that if we race light to the moon with these objects, light would only win by a total of 4 meters.
How does the Large Hadron Collider work?
The fastest man-made object in existence, a probe being sent to study the sun, will travel at over 700,000 kilometers an hour. That may sound fast, but light goes at over 1 billion kilometers an hour, so our probe is only traveling at a small fraction of 1% the speed of light. The objects we turn to when we feel the need for this much speed are subatomic particles. Protons are subatomic particles that are present in every atom. They're accelerated to nearly the speed of light by the biggest particle accelerator we've ever built, the LARC. Two positively charged particles will repel each other, same with two negatively charged ones. That's the key to letting us use electromagnetic fields to push these protons around.
Next is research.
Current research goes beyond the Standard Model to answer unanswered questions. Scientists are searching for dark matter and studying neutrino properties. Experiments at CERN and other laboratories aim to discover new particles of the universe.
And there are many observations and pieces of evidence for why dark matter exists. The way galaxies spin is determined by their mass. We can see the stars that make up the galaxy, so we can add up the mass in these stars, and we can guess, based on this mass, how quickly galaxies should spin. It turns out that this guess is wrong. It's very wrong. In fact, galaxies spin much faster, so people conclude that there must be some hidden component to the mass, which they call dark matter. There are different models for what dark matter could be. The best leads are judged by how much promise a particular dark matter candidate holds to explain other mysteries about the fundamental laws of nature.
Your morning starts with particle physics. Your phone's alarm works because of electrons flowing through semiconductors. Semiconductors work because we understand quantum mechanics. Quantum mechanics is part of the Standard Model. The Internet, born at a particle physics lab. Your morning scroll, powered by quantum principles discovered decades ago. You can't see electrons, protons, or photons, but they're in everything you touch, use, and need.
In the end, exploring tiny particles helps us understand the universe better, even though the Standard Model can't explain everything yet. By searching for answers, we don't just solve cosmic mysteries, we also create life-changing technology like medical scans and smartphones. So, every time we look deeper into the smallest parts of reality, we're also finding ways to make life better right here on Earth.